Right. We're going to start by looking at a review of Term 3 work on triangles, mathematics. Right. So we're going to be looking at, in the diagram below, the Leaning Tower of Pisa. AB is shown. We have this Leaning Tower, and it's shown here. The torus determines that the angle of elevation of the top of the building increases from 38 to 48,08 degrees after walking 20 meters towards the tower, right? From point C, here is point C, to point D. He also determines that point D is 50 meters from the foot of the tower. We can see point D is actually 50 meters from the foot of the tower. BDC is horizontal. So we have BDC is what? It's horizontal. And AB is not vertical. So AB is not vertical. Very important point there. Right. Here comes the question. The worksheet is asking the question, and they're saying, explain why angle DAC is equal to 10,08 degrees. Right, where is angle DAC? So you have D here, you have A there, and you have C there. So we're looking at this angle, we're saying in particular, what is the size of this angle here? Explain why this angle is equal to exactly that one, 10,08. Okay, right? So we can explain that with ease because we're able to see that first and foremost, this angle here is equal to this plus that. So in other words, we're able to see that angle BDA, right? Angle BDA, which is this one here. So we have this situation. We have this situation. So you have that BDA is equal to the angle they're talking about, angle DAC plus 38 degrees. So this angle is equal to this plus this. What is the reason for this? Why is this angle equal to this plus that? The reason is because we're dealing with the exterior angle of triangle. Right, so the exterior angle of the triangle I've highlighted in red is equal to the sum of the interior opposite angles. Right, so which means you have 48,08 degrees, which is angle DAC plus 38 degrees. Right, upon algebraic manipulations, well, because we can see that BDA, this angle is 48,08 degrees, from which we're able to find that DAC is actually equal to 48,08 degrees minus 38 degrees. Okay, we transposed the 38, and therefore if we add these angles here, what we're getting exactly is 10,08 degrees. 10,08 degrees. Okay, so yeah, that's perfect. That is what we're getting. That is what we're getting. So yeah, we have that. Let's look at the next question. They're asking the question now, determine the straight line distance AD. Give your answer the nearest two decimal digits. They want AD. Right, AD. Right, because it's 3 marks. Forgive me for that. Because it's 3 marks, I'm giving you like 3 minutes to try and see if we can be able to determine the straight line distance, AD. Right, A is here and D is there. Are you able to see that? Okay, if you can't see, please let me know. Okay, if you can't see, please do not hesitate to actually let me know that, say, I cannot see, and I'll then, be aware and I can do something about it. Right, so we have exactly these here. We have exactly these here. Right, so in view of these, right, so determine the straight line distance AD. Give your answer correctly to, so this one, A to D. So I'm giving you 3 minutes. Just 3 minutes only. Just 3 minutes only. Please let me know what you think the answer is in 3 minutes. Let me know when you're done. We're interested in finding the distance from A to D. If you can't see, please talk to me. Okay. Okay, let me know when you're done. Well, we want to find the distance from A to D. A to D. Right. So preferably you need to have your calculator ready as well, so that you can be able to do some of the calculations using your calculator. Okay, using your calculator.
Sir,
Yes, please. What do you think the answer
I'm a
is?
bit confused
Okay, that's
because
fine. That's okay. That's
when
okay. Uh-huh.
we're calculating the length of a line, we normally use Pythagoras or the sine rule or the tan
Yes.
rule,
Yes, that's correct.
but
That's fine.
I don't know how to calculate this. So can you please explain if you
Okay,
don't
that's
mind?
fine. Thank you. That's okay, because see, the reason why I'm bringing the questions, I'm bringing them so that we discuss them together. Okay, right. So, right, you remember that we. Yes, please. All right. Okay. The reason why I'm bringing these questions is because I'm trying to make sure that we learn through them. Okay. I'll be bringing worksheets. We shall be working through the worksheets together. And sometimes I pose questions. I know the questions sometimes are like silly, but the questions are just intended to help you to learn something. Right, so we know that this angle here, what is it? The angle DAC is 10,08 what? Degrees, isn't it? Right, so if we want to find right now the distance from A to D, so we basically have this triangle here. Okay, we have this triangle here, and this one is 20 meters. This one is 10,08 degrees. And then this one is D. Okay, so this one is the length of D. This one is the length of what? Of D. This one is C. This one is what? Is A. You get the point. Right, so with that said, so we're interested in finding AD here. So we are given this information, but we also know that this angle C is 38 degrees. So, which means with AD over the sine of 38 degrees, which equals right, so which equals AD over the sine of 38, it equals this angle, this side here, over the sine of 10,08 degrees. Okay, so what is this? Right, we cross multiply. If you cross multiply, this one goes there, meaning we're going to have AD is actually 20, the sine of 38 degrees divided by the sine of 10,08 degrees. Right, so we get this when we cross multiply. Cross multiplication brings this to the other side. We want to find AD. All right, so we have this. Okay, now we continue. I'll keep asking questions from time to time. So if you look at 20 sine 38 divided by the sine of 10,08, okay, use a calculator for this. The calculator will give you 70,35 meters. 70,35 meters. And this is exactly the length of AD. The length of AD. All right. And we're done. So if they say, give your answer correct to two decimal digits, and that is the answer. Okay. Why did we use the sine rule here? Okay. Because the sine rule is having a side angle, side angle, side angle, side angle. So with the sine rule, it means you must be given a side, an angle, and an angle. A side, an angle, and an angle opposite to the side that is desired. That must be determined. Okay, so that's something that's extremely important there. All right, so let's continue with the worksheet. Yeah, many questions I'm going to bring. Right, so if you look at like 1.1.3, determine the length of the tower AB correct to two decimal places. The length of the tower AB correct to two decimal places. Now we want to find the length of this tower, but you'll remember that this tower is leaning, so it's not strictly vertical, this. So since it is not strictly vertical, we can't use Pythagoras or anything because this angle is not 90. It's not 90. So what do we use? We can use, if we do not have a 90-degree angle in the triangles, we do not use the Pythagoras theorem, but what do we use? We use other rules, like your sine rule, your cosine rule. And so we continue. Right? Any of the rules will work here. So now we are dealing with a triangle. What triangle are we dealing with? Okay, there is the shape. So we're dealing with a triangle here, like this. This one is B, this one is A, and this one is what? Is exactly D. This is 50. This one is 48,08. AD we already know. Right, this one here we already know is actually 70.35. Okay, we have this. So we have these. Now having these, what do? We just need to find AB. So, but now we already know these two sides and the included angle. Knowing two sides and the included angle, we need to find. So in other words, we are dealing with the side angle side situation. Side angle side we know, right? So this is a geometrical way of writing this, the side angle side way of writing. So we want to find now the length of AB. So side angle side, we use the cosine rule. Cosine rule. Okay, I'm just revising these, and there are lots of questions I brought here, and we shall discuss them. So, which therefore means at this point we have AB squared. Right, because now we have the AB. This one equals A. This one equals B. And this one is D. All right, so we have this. Right, so to get this one, we want to find the length of AB. So we start with AB squared. Right, we say AB squared is equal to, then we take the other side. Right, we can take the A squared plus B squared minus twice AB. Cosine of the angle included. What is the angle included? Right, so you can write like that. And then the angle included is the angle D. It's the angle D. So we substitute. What is A? It's 50 squared. B is 70. A is 50. Okay. My goodness me. All right, so we have therefore the angle D as well. We substitute the angle D. The angle D is 48,08 degrees. Okay, so this is AB squared. Right, want to find AB. So which means therefore we get to this point. If we want to find AB, then we apply the square root. So AB therefore becomes the square root of all these, which is 50 squared. Plus 70,35 squared. Um, 70,35, which is 48,08 degrees. Okay, then we use a calculator here. If you use a calculator to find the square root of this, the calculator will give exactly 52,43 meters, which is the length of the tower there. So the length of the tower is exactly 52,43 meters. Okay, so obviously this is being recorded, so you don't need to copy anything down. Right. As part of an exercise, we are learning to prove things. So I want us to prove this as well. How do we prove this? Right, to prove this right now, we proceed as follows. To prove this, we want to find the length of AC. Right, so you have this one. Want to find the length of AC. To find the length of AC, you're going to work in triangle. ACE. So you have AC over these two. Okay, using the sine rule, you have AC over the sine of the angle opposite. So you have X and Y, which is X and Y. Okay, and this is equal to, we are dealing with a triangle ACE, so the triangle we're dealing with is this one here. I'm just shading the triangle like this. So it is AC over the sine of this, which is equal to CE over the sine of this other angle here. Okay, if this one is 90 degrees, this one is X, this angle here is 90 degrees minus X. 90 minus X. Because when you add all of them here, the sum must be 180 degrees, the sum of the interior angles of a triangle. So we take now AC over the sine of this. So we're working in triangle ACE. It must therefore be equal to CE over the sine of the angle opposite CE. So it's actually 90 degrees minus X. So we have AC. Right, we have these. We have this. So if you cross multiply these here, we actually now have that this sine of the X plus Y is going to go across. The equal sign giving our CE times the trigonometric sine of X plus Y. And this here is divided by the trigonometric sine of 90 degrees minus X. Now, what is CE here? What is CE? Okay, so we need to find the length of CE. Right, so you can see therefore that CE itself needs to be determined, but we need to think a little bit about it because we don't know exactly what it is, but we can find it. All right, so to find CE, we proceed as follows. Right, I'll just be here now. I'm going to pick another color here, like this. Right, I'll pick that color there. So, which means we just need to remember something, that we can work as well in this triangle here. This one. Okay. Work in that triangle there. This is Z, given like that. So, which means that if we decide to work in the smaller triangle, where we have, for instance, the sine of Y, the sine of Y is the opposite over the hypotenuse. So the opposite is Z over the hypotenuse is what? Is CE. So, which means therefore, we need to find CE here. We need to find CE. What is CE? Right. So to find CE, we cross multiply. If you cross multiply, CE is going to sit in place of the sign is going to sit in the bottom. So you have this one. Like this. So in the end, what we're getting is as follows. So which means that AC, then you have CE. What is CE? Right. So CE is exactly Z over the trigonometric sine of Y, like this. You can put it down like that. And then you have here the sine of x plus y, which you divide by. Now, in each quadrant is 90 minus. 90 minus, and I'm yet to discuss quadrants with you in detail when you discuss the reduction formulae. But 90 degrees minus is actually in the first quadrant where the sign is positive, but all trigonometric functions remain positive. And this is positive, but it changes to its co-function, cosine x. So we have AC, which is therefore z into the sine of x plus y divided by cosine x sine y. Cosine x sine y. How far are we? AC is equal to, this is what we're supposed to prove. AC is equal to z into the sine of x plus y divided by the cosine of that. Okay, so we have, we're discussing worksheets, and there are a lot of problems I have brought in this worksheet. So you shall learn a lot of the mathematics, both papers 1 and 2, but I want to also strengthen the paper 2 as well, as much as I'm going to actually reinforce a lot of paper 1 in the process. Okay, we proceed. So in 2.1, we have this one here. We need to prove this result. So in the figure below, you have been given the acute. In the figure below, we have been given an acute angled triangle ABC. The fact that this triangle is acute angled, it means that each of these angles here is less than 90 degrees, is acute. And this is drawn having C at the origin. Okay, so it's drawn having C at the origin, right? And we have exactly these. And we need to just prove this result here. We need to prove this result here, and it's very, very straightforward. How do we prove this result? How do we prove this? So there are many ways to prove this result. Because this one is a proof, I'm going to discuss it with you. There's some proofs I'm going to ask you to stretch your minds, okay, and demonstrate to me what you made of. But this one I'm going to do with you. Here we go. Right, so first you need to redraw this triangle. You redraw it like this. And then you put A here. You put B here. And then you put C there. You construct like this. Like this. Okay, so this is D. This is also what? D. So this one here is C, B, A, H. Okay. Then this is what? So this actually is the triangle. And we have just performed the construction. And so we have divided the triangle into two triangles. So here comes the proof. Right, here comes the proof. Right, to do the proof of this, we proceed as follows. Because you already have marked this, and this angle is 90 degrees, we did not have, we had acute angles in the triangle ABC. But now here, we have constructed, the construction has yielded a right-angled triangle. It has yielded this construction two right angles. Okay. Two right angles. So now, what do we do here? So we can work in this triangle here and say A squared is equal to BD squared plus H squared. So we can start and write A squared, this one is equal to BD squared plus H squared. So which means you have a squared. Right, so you have BD now. What is BD? BD basically is C minus, which is the C here. It's C minus AD. C minus AD plus. Then you have the H squared. H squared. Okay. What is this now? What is this here? So we note, therefore, that this is due to a result that we call Pythagoras. Because we use Pythagoras in this triangle because it is right angled, this one. Right, so we get these. From which we proceed furthermore, like this. Proceed furthermore like this. Right, so we have this, and this is then the same as a squared equals. You square these. C squared minus 2CAD plus AD squared. We have this. So what is A squared? Okay. So we have A squared minus, so what is AD squared plus H squared? Okay, I'm gonna look at that one. So here we can write here minus 2C. Okay, this one is a proof, so it's quite demanding to understand. But if we say H squared plus AD squared, H squared plus AD squared is B squared. Pythagoras theorem in this triangle here, in the upper triangle, because we have AD squared plus H squared, it is B squared. So this AD squared plus H squared is B squared, like this. Okay. So this one is A squared is equal to B squared plus C squared minus 2C AD. Okay, we get this here. We get these here. Okay. It remains to just work right now in triangle. We need to get this AD now. What is AD? This one here. So we're going to work in triangle ADC. Right, we're going to work in triangle ADC so that we have AD divided by, okay, we can start by like this. Okay, we can start like this. Right, so we start by saying cosine A, which is this one here, is the opposite. Right, or is right, the cosine A becomes the adjacent in view of SOHCAHTOA. SOHCAHTOA. So which means cosine A becomes the adjacent over the hypotenuse. Cosine A is adjacent over the hypotenuse, which becomes AD over B. The hypotenuse of the triangle is the side, the longest side of the triangle, but it is also opposite the 90-degree angle. AD is B cosine A. Okay, so we cross multiply here, we get AD. And then this AD, we can put it here. Right, so in other words, this one is equation 2. And this one is equation 1. 2 into 1. which means it's a squared b squared plus that minus 2c. What is AD? It is b cosine A. B cosine what? B cosine A. What is this? So this thing we've just got right now here is basically right. It's basically this. So here we've just written that a squared is equal to b squared plus c squared minus twice bc. Then we got cosine A. Right. So this here is the result. And this is actually what they asked us to prove, because they said prove that, or it's just that they just played around with the sides here. Played around with the sides here. You prove that c squared, and this is ab in that. Okay, but obviously you can see that the examiner wanted us to prove that c squared is equal to this. Right. So, in other words, the proof we've just done is similar to what the examiner wanted. And so I've demonstrated how we can prove this result using just some simple construction. And therefore, I'm going to leave this one as an exercise. So I'm leaving, therefore, this one as an exercise that says that you need to prove that c squared is that, because we proved the result for a squared equals that, but they wanted c squared equals that. It's okay. So now this one here that starts with the c squared, I'm therefore leaving it as an exercise. So in my next meeting, I'm going to inquire about the exercise. I'm going to inquire about the exercise. It can be done in many ways. Okay, I just demonstrated a method of proof. It's just a method of proof that we can use there. Okay, so just note that. Note that. Next question. Okay, the next question is about a garden. It's about Mr. New's vegetable garden. Mr. New's vegetable garden has angle K is 20 degrees, angle M is 100 degrees, and Km is 30 meters. Okay, let's look at the questions that they're asking in this worksheet. Calculate the length of the fence that Mr. New can use to fence his garden. Okay, calculate the length of the fence that Mr. New can use to fence his garden. Okay, so you have exactly that. Right, so let's think about this. So we need to find the length of the fence. Remember that this is a garden, everything here. The garden is like a triangle. The diagram below represents Mr. New's vegetable garden. This garden is like a triangle. But now we want to know the length of the fence that Mr. New has to use. So how much fence must be used? So we must find this length is there. We must find this length and that length, and then be able to add them together. Okay, and then now we can know the length of the fence that Mr. New has to use to fence this garden. Okay, so now we can find first some of this. We need to first find SK, and we must find this one. How do we find SK? Right, by the sine rule, we can just say SK over the sine of 100 degrees. SK over the sine of 100 degrees, right, is equal to what? It's equal to 30, this one here, over the sine of the angle opposite. This one is 100, this one is 20, and therefore this one is 60. 60. So which means therefore that SK is the same as 30. The sine of 100 degrees, which is divided by the sine of this. Okay, so if you use a calculator now, 30 sine 100 divided by sine 60, we just cross multiplied, okay? We cross multiplied. We're using the sine rule. Right, the calculator is going to give us SK is equal to 34,11 meters. Okay, we found SK. So we have that SK is 34,11. Okay, so this SK, the distance from S to K is 34,11 meters. Now we want to find SM also, so that we add them up. So we continue now, want to find SM. So if we want to find SM, we put it at the top. Then we divide, we say, divided by the sine of the angle opposite, which is 20, is equal to, right, $30 over the sine of 60 degrees, which is 30 over the sine of 60 degrees. Cross multiplying means SM, 30 the sine of 20. And then we have the sine of 60. What is the answer to this? Okay, if you multiply all these things, what they give you is 11,85 meters. So this one is 11, okay? 0.85 meters. Okay. So hence, right, length of the fence is the perimeter. Hence the perimeter. Now we're adding everything. The perimeter therefore is 30, which is this one, plus 34,11 plus 11,85. And then we add all these, okay, which are the length of the sides of this garden, okay? And then if you add all these up, they give the perimeter. And therefore, the perimeter becomes 75,96. 75,96 meters. 75,96 meters. Okay, we'll continue. Right, we continue. Next question. How big is Mr. New's vegetable garden? How big is Mr. New's vegetable garden? Okay. I'm giving you 3 minutes to try 2.2.2. We shall do it, of course. If they're asking the question, how big is it? I'm giving you like 3 minutes, please. You scribble. Okay. Please let me know when you're done. Okay, so let me know when you're done. Okay. All right. Okay, I'm here. I'm here. All right, I'm here.
So I'm still busy.
Okay, that's fine. By saying I'm here, I don't want you to think that I'm gone. Okay, so yeah, because you can be like, maybe it's gone.
So
Yes, what do you think?
is it correct if I say
Uh-huh.
60 is equal to half of um 30 dot 34.11 sine 20? Because I substituted the values that we got.
Yes, that's correct reasoning. That's correct reasoning.
Yes.
Right, that's correct reasoning. Okay, so we're gonna do it now together so that you'll just compare. Okay, what answer did you get at the end?
So I'm not done yet with
Okay, that's fine. That's fine.
my
That's okay.
calculator
Okay, you need
problems.
to use the
I'm
calculator and
struggling.
things. Yes, that's okay. That's okay. That's okay. Um, okay.
So is it correct if I use the area rule?
Yes, it is correct if used because they're saying, I wanted to see your reasoning because if they say how big, they want the area. Okay. So if they say how big, what do they want? They want the area. So I wanted you to see just your analysis there. Altogether. So I wanted you to get to think about this. So yeah, okay, that's correct reasoning. So in other words, they're interested in the area. So to find the area of this, we say that the area of this triangle here. So obviously we understand that this one here is the side K, small k, because opposite angle K. Opposite angle M is small what? Small m, you understand? So which means that you have half. Right, so you're gonna have half. This one is s, small s, right? So you can use half ks, right? You can use half ks, the sine of 100, like this, or the sine of the angle m. Okay, the sine of the angle m, for m here, which is half. K is what? K is this one 11,85. So S is 30. The sine of the angle included. So you have a choice. You can use any of the sides here. So we decided to use K and S. Right. So, but this one is 100. So which means that Mr. New's garden is going to have the area of 175,05 square meters. Okay. So that is what we have. So this is the answer. So how big is Mr. New's vegetable garden? It is 175,05 square meters. Okay, that is how big the vegetable garden is of Mr. New. So just something to note. Next question. Next question. So if you look at 2.3, if the garden was rectangular shaped, determine the length of the length of the garden if it has a width of 13. Okay, so we just need to find the length if the width is what? Is 13. So let's do this one here. So obviously we remember that to do this question is very, very easy. Right, so I'll just do it. And then I'm going to give you some of the questions to try. Okay, but some I'm just going to do them. Like this one, let me just do it with 3 marks, very nice and easy. Right, we have been given, if you're given the length, right, you are asked to find the length, determine the length, and the width is given to you. So this is the width. The length is what is required. So you have to know that the perimeter is twice this. Which is 70. Now the perimeter is what? The perimeter, now the perimeter, we found it before. We found it to be 70,9675. So which means the perimeter is 75,96 is equal to twice the length plus twice the width, which is 13. All right. So we get this one. We use a calculator now. We move across the screen and we have twice L, which equals. So if you say the 75,96 minus 26, it is 49,96. Is 49,96 divided by 2. Okay, so if you use a calculator, you get 24,98 meters. So this has given us the length, because it said we must find the length if the width is that. So we found the length just using the perimeter formula, just a different pattern of reasoning. Okay, let's look at the next question. Okay, they might not ask the sign rule only, but they might give some other shapes like this one. You know, they can ask you to calculate the volume and total surface area of a sphere given the length of the radius. For example, write the answer correct to how many decimal places? To 5 decimal places. The volume of a sphere is 4/3 pi r cubed. And the total surface area is 4 pi r squared. So what is therefore the volume of the sphere? Here. Because you have been given that the radius is what? Is 3,5. Right, so if the radius is that, it means therefore the volume of the sphere is this. So the volume of the sphere is 4/3 pi r cubed. So it is 4/3 pi. What is the radius? The radius is 3,5. Okay, if you calculate this, is 179,54438 cubic centimeters. That will give us the volume of the sphere. Because they said calculate the volume. But you must also calculate the total surface area. The total surface area of a sphere. What is the formula for the total surface area of a sphere? It has already been given, is 4 pi r squared, because the volume of a sphere is 4/3 pi r cubed, and therefore the volume of the total surface area is the total surface area is 4 pi r squared. 4 pi. What is the radius? 3,5. You square these. You multiply these things. 153,93804. Total surface area is the square. All right. So this is what we get. Because they asked us to find total surface area of a sphere. So it's like finding the total surface area of a soccer ball, or you can imagine a soccer ball, or imagine something like a tennis ball. And now if you have a tennis ball, a soccer ball, and you find the total surface area, it is actually this, like 153,938,04 square centimeters. Right, so you have also the volume, which is exactly 179,59438. Next. Um, 3.1.2. This one, if the radius is doubled, calculate the volume and total surface area of the larger sphere. Okay. If the radius is doubled. Right. So if you double the radius, what happens to the volume? So we're interested in the volume. Okay, so we continue. Okay, so what is the volume of the largest sphere? The volume of the largest sphere? The volume of enlarged sphere. Um, um, so we continue. So volume of enlarged sphere is the same as what? So the volume of the enlarged sphere, you double. So there are two ways to do this. If you double the radius, you multiply these by 2. So there's a 2. And the 2 you multiply by, it's going to be cubed. So you can just take the volume that we got, which is 179,59438. You multiply because now it's going to be affected by the cube, and therefore it is the 2 cubed. And then you get the answer out of this, which is exactly 1436,76 cubic centimeters. Okay. So now the total surface area, the total surface area we continue. So the total surface area is this one, which is 4 pi r squared. So it means here you're gonna just do what? Okay, because this total surface area, if you double the radius, it's going to be squared. So there's going to be a factor of 2 that is going to affect this. So which means that the total surface area, you will take the 153 that you got here, 153, 93804 multiplied by 2 squared. Multiplied by 2 squared. So if you use your calculator here, for the total surface area enlarged, right? Total surface area. So it's going to be 615. It is 615,75 squared. We have this. We have this. Okay, so you continue. Okay, so this becomes the answer. This becomes the answer. Next question. Because if the radius is doubled, we're to just find the volume, which we have just multiplied by 2 cubed. Why 2 cubed? Because you just look at the radius. If it's doubled, then the radius is being cubed. So you take the 2 that is doubling, and then you cube. But also here, you double the radius. So it means the radius here is going to be multiplied by 2 squared. So which is that? Use the figure below to answer the questions that follow. Calculate the volume of the triangular prism. Okay, let me give you like 2 minutes. Let me give you like 2 minutes. Okay. So we have this. Let me give you like 2 minutes to find the volume of the triangular prism, and I'm going to give you the answer after this. Okay. All right. Okay. Let me know when you're done. Yes.
The volume is half times B times H times length, if I'm correct.
Okay.
of the volume.
All right. Right. Okay. I can hear you. So yeah, let's just analyze that together. So we're looking at 3.2.1 and we want to find the actual volume of the triangular prism. Right. So what did you say again? Please repeat yourself. I just want to evaluate if you're on the right path.
Half times b times height times length.
Yes.
So it's half
So,
times.
yeah. So the volume, you're on the right track. So the volume is half. Is half the length. Right. So there are a couple of ways to do that. You can do half base by height, or yeah, half base by height multiplied by so in other words, this is how we do it. Generally, to find the volume of a prism, let me just give the general formula here. Right, so to find the volume of a prism in mathematics, we always say area. We say area of base multiplied by the what? Multiplied by the perpendicular height. What is the base? So now this triangular prism, you can look at it from here to the other side. So which means that here you have half base by height, if you like, for the triangle. And then you multiply by the other dimension. Right, so half base by height multiplied by the height of the prism. Right, so which means it is half the base. The base is what? You can take the base to be 15, or you can take the base to be 18. So you can say half the base, which is 18, times the height, which is 15. Okay, we understand that this one is sort of the height of the prism, which is 14. And what is the answer? Right, so you're going to just do this one. All right, so we actually have this, which is, if you use a calculator, is 1890 cubic centimeters, because now we are doing the there are 3 dimensions. We're multiplying here. We're multiplying the 18, and each one is in centimeters, etc. Okay. Oh, you got the same answer, hey? Thank you so much. That's excellent. Okay, so I'm glad that you're on track, because these kinds of worksheets are just there to test your understanding, but also to get you to think a little bit during our discussion, which is something that I'm going to be working on, so that you're not just the person who is always spoon-fed, but you are the person who is the student who thinks. Okay, let me just give you 4 minutes, and then you try 3.2.2, then we're gonna do it together. You're gonna see the answer. Okay. Yeah, I'm just trying to train you a little bit so that you are a student who is not not spoon-fed all the time, and who can always be in a position to get things as well. Okay, let's try that, please. Okay. Right. Okay.
So I forgot the surface area for
Is it?
formula.
Okay, that's fine. Okay, because yeah, I just need to I tease your mind so that you don't sleep, you see. Right. So that is the reason why sometimes I'm like, okay, what do you think about this? So right, so the 1 to 6.2, so you're gonna do it here. So here we're gonna do this is 3.2.2. Right, in 3.2.2, there are a couple of things you need to notice. We're gonna first have to find the length of this hypotenuse because it's not known. So length of the hypotenuse. So the length of the hypotenuse becomes the square root of 15 squared plus 18 squared. Right, so you have then 23,43 centimeters. So this one is 23,43 centimeters. What is the total surface area? Total surface area. Right, so the total surface area becomes all right. So now we're gonna have, for example, half 15 by 18, half 15 by 18, but there's a triangle here, there's another triangle on the other side because this is a three-dimensional shape. So it's gonna be two of the triangles. And then you have the 23,43. Okay, the 23,43 is like a rectangle, this one. So you use length by breadth. So it's 23,43 by 14. Okay, 23,43 by 14. So you are dealing with, so you have found this side here and the other side here, there, this one. And then now you're going to deal with the base of the shape. The base of the shape is going to be 18 by 14, but it's rectangle. 18, yeah, it's 18 by 14, but it's a rectangle. Then you have the side at the back now, which is the side of the back is 15 here and then 14 because this 14 is the same as that. So you have plus 15 times 14. 15 times 14. So you get the answer. Total surface area. For 1060, 1060,02 square centimeters. So that is the total surface area of the shape, you know. So just note that it is the total surface area of the shape. Next question. In this question, we're looking at this tank. So I'm going to give you like 4 minutes to try this tank, and then we shall do it together. I want to see what you're going to do. You'll forgive me because I sometimes give you so that you shake your mind a little bit. I'm avoiding sleeping, and then we're going to do the corrections. If you have never seen something like that, you tell me, because I'm trying to make sure you think with me. I'm trying to make sure that you think with me. Okay. Like 4 minutes. Okay. You let me know, please, when you're done.
Almost done, sir.
Okay, thank you.
Sir, I got 221.52.
All right, let me check. Let's check together. We're going to do it just now together so that we are able to verify exactly what the answer is to this. And now it is extremely important for us to do so. Right, it's very important for us to do so. Let's just get cracking. Let's get cracking. Let's get cracking. Right, to understand that obviously this is a very, very simple question, but we are practicing so that we prepare for the exam, but also we look at how the formulas that appear in the exam are actually used to solve these problems, because it's very important that we understand what's happening. Okay, right. First and foremost, we know that the volume is equal to pi r squared h. Right, and obviously this becomes the area of the base. So in other words, we say that the volume is equal to area of base by the height. So what is the area of base? It's by the radius. Okay, the volume is this. Okay, so you have everything already. So if need be, you can just substitute straight away, and then make the subject at a later stage. Like you can come and say the volume is 260, and then it's pi. And then the radius is 3,5. Okay, so you put 3,5 here. You square these times h. Right, then you need to get the h. So how do you get h? So divide by pi into 3,5. Divided by pi into 3,5. To divide. We have this. Right, so if you divide everything, so you have the 260 divided by that, which is exactly 6,76 centimeters. How close is it to what you got? You got about the same answer.
I forgot that when we multiply, we must divide. So
okay.
I messed up there.
Okay, that's fine. That's fine. Note that obviously this lesson is recorded, so you're gonna have access to the recording. The voice quality and the sound will be consistent. It's not gonna be like changing or anything. All right, so we continue. Have you done finance yet? No. Yes. Yeah, I did it grade 10.
Also, we're going to do finance this term, but yes, we did finance last year.
Last year. Okay, that's fine.
But for this year, we're only starting this term.
Yeah, that's okay. You did probability. Not yet.
No, sir.
Okay, that's fine. All right. Okay. I want us to do some finance questions. Okay, let's start with this ones here. On probability. Right, so these questions we are doing now are actually on probability. So we continue. Okay, so we have this. Okay, now let's just do some probability questions quickly, and then there are certain things we call the Venn diagrams. I want us to sort of discuss here. Okay, like in this question one, given events A and B, the probability of A is what? Is 0,7. The probability of B is 0,3. The probability of A and B is 0,2. Are events A and B mutually exclusive or not? So let's look at this question and to think together. Are events A and B mutually exclusive or not? Right. Um, um, okay. Are they mutually exclusive? What are mutually exclusive events? Two events are mutually exclusive. This means that the probability of A and B is equal to what? Is equal to 0. So if events A and B are mutually exclusive, it means that the probability of A and the probability of B is what? The probability of A and B is 0. Right. So are the events mutually exclusive? Explain your answer. Well, obviously the answer is no. The answer is no. Right. So here in 1.1.1, 1.1.1, events A and B are not mutually exclusive. Since the probability of A and B is actually not equal to what? Not equal to 0. Okay, we're learning probability here together. Okay, we are discussing worksheets and I'm yet to give you like some questions to try with me. And then each question you just try and I give you the answer. We discuss the answer together so that you learn. Right, so are events A and B mutually exclusive? Explain your answer. So we can see clearly that at this point, the events A and B are most certainly not mutually exclusive because mutually exclusive means that the probability of the intersection is 0. But here you have that the probability, we have already been told that the probability of A and B is 0, 0.2. So it's not 0. So it means they are not mutually exclusive. Are events A and B independent? Explain your answer. So here we are dealing with the probability of A times the probability of B. What is the probability of A? The probability of B. So you multiply them. If you multiply, okay, for independent events, you multiply. If for independent events, you what? You multiply. Probability of A times the probability of B. So it's 0, 0.7 times 0, 0.3, and then you get 0, 0.21. Then you have the probability of A and B. The probability of A and B is equal to what? It's equal to 0, 0.2. You have been told that the probability of A and B is 0, 0.2. But this means that here, the probability of A and B is different from the probability of A times the probability of B. Okay? Is different. So the probability of A and B is different from the probability of A times the probability of what? Of B. So because they're different, these, it means therefore the conclusion is that they are not independent. Not independent. Why? Because independent means the probability of A and B must be equal to the probability of A and the probability of B. So they are not independent. Okay, next question. Rudy. Right. Rudy sometimes gets a lift to and from school. So Rudy is often given a lift to and from school. When he does not get a lift, he walks. Okay, there are days that Rudy is given a lift, but sometimes there's no lift, so Rudy needs to walk. Okay. Okay. Right. Okay. Right. So we have exactly that. We have exactly that. Okay, we have exactly that. We have exactly that. We have exactly that. So we continue. So we continue. We continue. Okay, right. So now the probability that he gets a lift to school is 0.4. And then the probability that he walks home from school is 0.7. Okay. Getting to school and getting home, getting to school and getting home from school are independent events. So we have independent events. What does it mean to say the events are independent? So independent events means that the probability of A and B the probability of A and B is equal to the probability of A times the probability of B. Like that. Okay. So now, getting to school and getting home from school are independent events. So you can say getting to school and getting home from school. So getting to school has maybe is the event A, and getting home from school is the event B. So if they're independent, it means that the probability of A and B is the probability of A times the probability of what? Of B. Okay. So we have that. All right, so we have that. So we continue. So we continue. Okay, we continue. So draw a tree diagram to represent the information. Write the all probabilities. So we have 1.2.1. Okay, I know that okay, now let's draw this tree diagram now together. Let's draw this tree diagram about Rudy. Okay. Okay. So we continue. All right. So what is the tree diagram here? Let's just draw the tree diagram together. Let's draw the tree diagram together. So now it's either Rudy gets a lift. If Rudy does not get a lift, what does Rudy do? Rudy walks. Okay, Rudy sometimes gets a lift to school and from school. When he goes to school, okay, when he does not get a lift, he walks. He takes a lift or he walks. The probability that he gets a lift to school lift is 0.4. The probability that he walks home from school is 0.7. Getting to school and getting home from school are independent events. Getting to school and getting home from school are independent events. So also here, either Rudy gets a lift or Rudy walks. Okay. Okay. Either Rudy walks or Rudy gets a lift. Also here, either Rudy gets a lift or Rudy walks. Okay. Okay, we'll continue. Right, so we continue. Okay, there are two possibilities here in 1.2.1. Rudy sometimes gets a lift to school, to and from school. When he does, okay, so I'm reading here, when he does not get a lift, he walks. The probability that he gets a lift to school is 0.4. And the probability that he walks home is 0.7. Okay. So we have exactly that there. We have exactly that there. So now, draw a T diagram to represent the information. Write all the possibilities. or the probabilities on the branches. Okay, I want you to note a couple of things, obviously, as we look at this question. Either if he gets a lift is 0.4, if he walks is 0.7. If he gets a lift here is 0.4, the lift, and if he walks is 0.7. The lift is 0.4, walking is 0.7, and you have exactly that. Draw a tree diagram to represent the information. Write all the probabilities on the branches. Write all the probabilities on the branches. Okay, so we have this. So you have this here. Okay, so you're going to have that tree diagram there. Just note that. What is the next question? Calculate the probability that Rudy walks at least one way. So in other words, when Rudy is going to school, either Rudy takes a lift or Rudy walks. On the way to school. And on the way back, he either gets a lift or he walks. Okay, so that's why there are two of these levels. So it's to school and back home from school. Okay, so that's why we have this kind of a tree diagram. In 1.2.2, calculate the probability that Rudy walks at least one way. So let's look at that one in 1.2.2. Right, so in 1.2.2, the probability that Rudy walks at least one way. Okay, which means that we have the probability that it is the probability that if he walks at least one way, is the probability of the lift walking, or the probability of walking then lift, or the probability of walking. Because now he walks one way, so he can get a lift to school, but then he walks when he goes back. Here, either he walks to school and then a lift back home, or the probability of the fact that because it's at least one way. So at least means one way or more. So he walks to school and he walks back home. Okay. So what is this? So which is the same as the probability of lift then walking, or is the same as plus the probability of walking to school and then a lift back home, or the probability of walking to school and walking back home. Right. So what is the probability of getting a lift to school and then walking back home? Right. So the probability of getting a lift and then walking. So it's 0.4 for the lift, and then it is 0.7 for the walk. Right here, if he walks and then he gets a lift. So walking is 0.7, and then the lift is what? The lift is 0.4, like this. Okay, so you have exactly that. So the probability of walking is 0.7 times the probability of the lift, which is 0.4. All right, so you get the answer to all these here. Right, you get the answer to all these here. What is then the answer to all these here that we get? So it means, therefore, you multiply this one. When you multiply this, you get 0.28, 0.28, 0.28. Okay, and then if you add everything, you'll get the answer to this. In other words, it will be 3 into 0.28. And then you can see what we get when you use a calculator. Let's just do the brief calculation here. Let's just do the brief calculation here. Zero 0.84. Right, so it's just about 0.84 there. Okay, so which is the probability of the fact that it walks at least one way. Next question. Okay, let's do a little bit of finance. Right, so now to do a little bit of finance, right, let's do a little bit of finance. Okay, let's do this one. 8,000 is invested for 5 years. So we invest 8,000 for 5 years at an interest rate of 17% per annum compounded monthly. Determine the value of the investment at the end of the 5 years using the nominal interest rate. Nominal interest rate. So when we talk about the nominal interest rate, we use a formula. So which means, therefore, this is 8,000. Okay, it's invested for 5 years. What is the interest rate? It's 17%. So you divide by 100. What is the, but it's compounded monthly. So M is 12 in view of the nominal interest rate. And then now for 5 years, number of years is 5 and M is 12. We use the nominal rate, M. If you use a calculator, this is actually 8,000 into 1 plus 0.17 divided by 12. You have this one, it's 60. So if you use a calculator, it is exactly 18,605 rand and 87, like this. Okay, so this is the value of the investment at the end of 5 years using the nominal rate. What about if we convert the nominal interest rate to an effective interest rate? Okay, so we need to learn that we're learning two kinds of rates, the nominal interest rate and the effective interest rate. So the effective interest rate now is calculated as follows. So you need to just convert the rate. So this is the formula that we use in 4. 4.1.2. Right, point 2. There we have this. So we cut this. So which is 4.1.2. Okay, the formula for the nominal rate and the effective rate. So we learned that 1 plus the effective rate, I effective, is equal to 1 plus I nominal divided by m to the power m. So which means therefore I effective is the same as what? Is the same as what? Okay. Right, so I effective, now if you want to find the I effective, we just move the 1 to the other side. So it means therefore you have 1 plus I nominal divided by m to the power m minus 1, which means I effective, which is 1 plus. What is the nominal rate? Right, so obviously we've learned of the nominal rate here because we were told that this interest rate is that compounded monthly. So now we used that rate. So which means that we're going to have 17, which is 0.17. Okay, 0.17, divide that by 12, and you raise it to 12 minus 1, which means the effective rate is the same as, okay, let's just do this one. Right, so to do this one here, we just need to which is 1 plus 0.17 you close here. So you have this one. Okay, so this one is 0.18389. Okay, 0.18389. Okay, that's what we're getting. Remember, this is recorded in case the sound breaks and the network is not perfect throughout. Okay, so anyway, this is what you're getting. Right. So which means you multiply by 100 here. You multiply by 100, it becomes 18.389%. Okay, so that is what you are going to get. And this one is the effective rate. So the effective rate, we converted a nominal rate to an effective rate. Now, use the effective interest rate to calculate the value of the investment. Comment on your solution and that in 4.1. Okay, now we need to use the effective rate to calculate the value of the investment. Let's use the effective rate to find the value of the investment. Right, so in 4. So this one now is actually A into P into 1 plus I to the power n, which is the same as 8,000 into 1 plus, what is I? So it is 0, 0.1838. Nine. And then you raise it to the power 5 years because we're dealing with the effective rate now. So we're using years here. And if you do this now, you use a calculator for this, you're getting exactly, you're going to get 18,605,88. Okay, and therefore this one here is the effective rate. The effective interest rate is 18,605,88. Okay, so we have used the effective rate, but in the first case, we used the nominal rate. All right, so we know the difference because if you use the nominal rate, you use the formula A equals P into 1 plus I over M into N by M. Okay, this one is for the nominal rate and this one is for the effective rate. The effective rate, therefore, it's per annum and this one can be per month, etc., per quarter. Right, so obviously you have 8,000. I'm just trying to demonstrate the difference there adjacent to. So you have this one divided by 12, and it is exactly what? It is exactly 5 by 12, which is 18,605,87. Okay, that's what we get. Next question. Four point 1.3. 4.2. Let's speak about Zakele. Zakele inherits 10,000 and invests it in an account for 8 years. If the interest rate for the first 4 years is 8.4% per annum compounded half yearly, and then rises to 9.2% per annum compounded monthly for the remainder of the investment, calculate how much interest he has accrued on his inheritance. Let's talk about Zakele and the inheritance. So how much did Zakele inherit? Zakele inherited 10,000. After Zakele inherited 10,000, right, and invest in account for 8 years. If the interest rate for the first 4 years is this, and compounded half yearly, and then rise it to this, compounded monthly for the remainder of the investment, it is an 8-year investment. So you have 4 years, 8.4, and then 9.2 for the remainder, another 4 years. Calculate how much interest he has accrued on his inheritance. All right, so remember that at this point, we're speaking of Zakele. Okay, he inherited 10,000. Okay, he inherited 10,000, but the interest rate has been 8.4% compounded half yearly. So you divide 8.4 by 100 and you get 0.084. Because half yearly, it's twice a year. And then it's 4 years, so it means that it is 4 times 2. 1 plus. Then you have another 9.2% compounded monthly. Okay, so you divide this one by 100. So dividing this one by 100 means that you have 0.092. Okay, this one is compounded monthly, so you divide by 12. And then At the top is another 4 years, you multiply it by 12. And then use a calculator to get the answer. And therefore, this one here, if you use a calculator, you get 20,000, 051, comma, 76. We're asking the question, how much interest he has accrued, how much interest he has accrued on his investment. So the interest, how do you find the interest? So we say the interest is going to be this future value, 051,76 minus 10,000. And then if you subtract this now, it gives you exactly 10,000 is we're minusing the initial investment. So which means that this one is exactly 10,000, 051,76. Okay, then in 4.3, Sipho invested 15,000 in a bank account. After 5 years, he withdraws 28,000. Calculate the interest rate rounded to 2 decimal places for the per annum if it was compounded half yearly. Okay, so we get this here. So we get exactly that. So in the case of Sipho invested 15,000 in a bank account. So 4.3. All right. So which means that we're going to use the formula A for compound interest, which is this one. He invested 15,000 in a bank account. After 5 years, he withdraws 28,000. Okay, so now what we're seeing here is that 28,000, which is the amount he withdraws, but he invested 15,000. 15,000 into 1 plus I is compounded half yearly. We can do it like this and use the effective rates. Okay, so obviously because it is in 5 years, two by 5. Which is 15,000. So you have this. With a 10. All right, we solve for I. So to solve for I at this point, we will have 1 plus I, 10. 28,000 divided by 15,000. Right, you subtract everything to get I. I'm so sorry. I'm so sorry that I lost you. I'm so sorry that I lost you. It might just be the network. Right, if you use a calculator for this one, you get, okay, the video is not going to be cut. Your video is going to have continuous tuition, so it's not going to be cut. Okay, if you use a calculator, the 10th root of this minus 1 is 0,0, then you have 644,044. So this one is going to be the I. But because it's compounded half yearly, it's compounded half yearly. So what we're going to do here is compounded half yearly, so which means that you have the R divided by 2 times 100, which is the 0, 0.064444 R 0.064444 times 200 divided by, okay, just times 200, not division. Well, cross multiplying 2 times 100 is 200. So as a consequence, what we're getting here is that R is the same as this one times 200. Let me just check using a calculator here. Let's check using a calculator. So use a calculator to say 0.0644 times 200. Be 0.0644 times 200. Right, what I'm getting here is 12.88088%. That is what we have. Okay, so this one here is the okay. This one here is the, because they said calculate the interest rate rounded off to decimal places per annum, compounded half yearly. If it was compounded half yearly, so the rate per annum is actually 12, that. Okay, so okay, we did some finance, and then we shall discuss again when we're gonna meet. We can take a break tomorrow and meet the day after, but you'll talk about it. You'll let me know if you have the energy to continue, because we need to go in depth. We need to go much in depth in our next lesson. But tomorrow I can give you a break. You pass through these things and make sure you understand them. You need to have a book where you note down the questions and the answers. I know it's a bit more work, but yeah, you need to do that, because I'm yet to send you some worksheets that you can work on. Okay, but I think I must thank you for joining us today. Let me know if you're going to make it on Wednesday. If not Wednesday, let me know Thursday. If not Thursday, Friday. If not Friday, obviously we decided on Saturday and Sunday. Yeah, but let me know if you can have some chance Wednesday, or Thursday or Friday, etc. Okay. Right. I lost you. Okay. Thank you. Goodbye.